The derivative of cosine is negative sine. The derivative of tangent is secant squared. There are proofs to show all of this, like taking the limit of trig functions to get these derivatives. I'm not going to take the time to go through that. So to you, it's just going to look like this is this because we say it is. When really there's math behind it. We're just not going to take the time to do all the proofs to prove it. If you want to look those up on your own time, feel free. I know you all are going to go home and do that, right?
Yeah.
The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. Okay, we got one more. Derivative of cosecant is negative cosecant times cotangent. That's it. That's the 6 trig functions. So when you're working problems and you're having to take the derivative of functions that have trig functions within them, if you have to take the derivative of sine, it's cosine. If you have to take the derivative of tangent, it's secant squared, and so on. So you guys will have to reference this list a lot as you're working, but hopefully the more of these that you work, you'll be able to remember, like the derivative of sine is cosine and cosine is negative sine. All that. Let's do some examples. Instructions, differentiate the following functions. Differentiate means find the derivative. In part A, we have g of x equals 3 times the secant of x minus 10 times the cotangent of x. Okay, so before today, we talked about if we have a coefficient in front of a function, when we take the derivative, the coefficient stays, and then we take the derivative of the function. So like, if we have 3x squared and we're taking the derivative, the 3 stays, and then we take the derivative of x squared. Bring the 2 down in front, x to the first power. And then we get 6x. So it's going to be the same thing for trig functions. These coefficients that are in front of the trig functions, those stay, and then we just take the derivative of the trig functions. So g prime of x, when we take the derivative, the 3 stays, and then we take the derivative of secant, which is secant times tangent. And then we're subtracting 10 times cotangent. The 10 stays, and we take the derivative of cotangent, which is negative cosecant squared. The only thing that's left to do here is to multiply negative 10 times negative cosecant squared. The negative times negative will just change this to a plus. So we get 3 secant tangent plus 10 cosecant squared of x. That's it. That's our answer. Okay, part B. We have h of w. It's kind of an odd notation for a function. It's not wrong. You just don't see h and w together like that very often. Three w to the negative 4th power minus w squared times tangent of w. Okay, let's take the derivative, h prime of w. This first term doesn't even have a trig function in it. We can just work this the same way we have up until now. 3w to the negative 4th. The negative 4 is going to come down in front, and it'll get multiplied by the 3, just like we did over here with the 3x squared. So we'll have 3 times negative 4, which will give us negative 12. And then we subtract 1 from the original exponent to get negative 5. Second part, minus w squared times tangent of w. We have to do something a little bit different here. So we can still subtract. That's going to stay the same. But then what we have is 2 functions being multiplied together. In example A, those were just constants, a 3 and a negative 10 being multiplied by these trig functions. There's no variable. Now we have a variable in this first part. It's not just a coefficient anymore, it's another function. So what we have to do with this part is use the product rule. So remember, f times g prime is f prime times g plus f times g prime. So the derivative of the first times the second plus the first times the derivative of the second. That's what we're going to have to do to take the derivative of this part. So since we're going to end up with more than one term when we take the derivative, let's put it in parentheses because we're subtracting the whole thing. And so our signs are going to change a little bit after we do this. Okay, so the derivative of the first function, the derivative of w squared, is 2w times the second function as is, so times tangent of w, plus the first term as is, so w squared, times the derivative of the second. So the derivative of tangent is secant squared. Everybody good so far? Sure. Okay. Really the only thing left to do is distribute this minus sign. So when we distribute the negative, it's just changing the sign of both of these terms. Negative 12w to the negative fifth minus 2w times tangent of w minus w squared times secant squared of w. That's it. Well, that's it for part B. We got two more parts. Part C, y equals 5 times sine of x times cosine of x plus 4 times the cosecant x. Okay, when we take the derivative, this first part here, we've got two functions being multiplied together. So we're going to have to use the product rule again. And rather than just pulling this 5 out, we're going to attach it to the sign. So we're going to say 5 sine of x is our first function, and cosine of x is our second function here. The reason for that is if we pulled the 5 out, we might end up distributing it later and ending up putting the 5 in more places than what it actually belongs. So it's easier just to attach the 5 to one of the two functions and work with it that way. Okay, so y prime, when we take the derivative, we're using the product rule first. So we really don't have to use parentheses because there's not going to be a sign in front of it that's going to change anything. But we're going to take the derivative of the first term. So the derivative of 5 times sine, the 5 stays, and the derivative of sine is cosine. And that gets multiplied by the second function as is, which is cosine, plus the first function, which is 5 times sine, times the derivative of the second. So the derivative of cosine is negative sine. Then we have to take the derivative of this 4 times cosecant. So we've got plus 4. Since that's just a number, it's just a coefficient, it can just stay. And the derivative of cosecant is negative cosecant times cotangent. Cool. Okay, we can rewrite a little bit here.
So is this FD prime equals F prime P? Is that what we're doing? Or what?
Yes, well, that's the product rule, and you have to use that to take the derivative of things that are like two functions that are being multiplied together.
Okay.
So to take the derivative of just this part, we had to use the product rule.
Okay.
And now we have cosine times cosine, which we can write as cosine squared of x. And then we have a positive times a negative. That's going to end up being negative, so we can just change that plus to a minus and write this as 5 sine squared. And then we have a negative to deal with in this last term, so that's going to make that minus 4 cosecant x cotangent x. Last part to example 1, part D. P of t sine of t over 3 minus 2 cosine of t. So now we have two functions that are being divided. We'll have to use the quotient rule to take the derivative. Quotient rule f over g prime is f prime times g minus f times g prime over g squared. So we're going to use this quotient rule to take the derivative here. So p prime of t. It's the derivative of the numerator. So our numerator is sine of t. The derivative of sine is cosine. Times the denominator, which is 3 minus 2 cosine of t. Minus the numerator, sine of t, times the derivative of the denominator. Okay, the derivative of the denominator, we take the derivative of 3. The derivative of a constant is 0. I'm not going to write that. And then the derivative of negative 2 cosine of t, the negative 2 stays. The derivative of cosine is negative sine. Lots of parentheses. All of that is over the derivative, 3 minus 2 cosine of t squared. Okay, let's see what we can simplify here. First thing, we can distribute this cosine.
Where does that in parentheses come from?
This one, it's coming from here.
You have an extra parentheses.
Yeah. Open, 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 close, close, close.
Because the first one's for the peg, second one's for the sign, and then the third one's for the. I didn't get the third one.
Yeah, it's a lot.
From.
It's too much, honestly. But we're going to simplify it right here. Distribute the cosine, we get 3 cosine of t minus 2 cosine squared. And then over here, we basically have sine, well, negative sine times -2 times negative sine. Negative times a negative is a positive, times another negative is negative. So we'll use a minus sign. And then we've got 2 sine squared of t. And all of that, we're not going to multiply out the bottom. We're just going to leave it as 3 minus 2 cosine of t squared. I'd be happy with this as a final answer. They go one step further in the notes, so I'm just going to show you how we can do that.
Students, please excuse this announcement. At the end of this announcement, we will be doing our mandatory fire drill for the month of February. Again, this is just a fire drill for the month of
I feel
February.
like we just did a fire drill. Okay, those of you on Zoom, take a break. We'll be right back. We're back. Okay. We're close to being done with notes. I was trying to tell y'all something. Yes. There is a little bit more simplifying to be done using a trig identity, which you may or may not know. That trig identity is something else that is kind of like our derivatives today, that there's a proof to show that this is true. I'm not going to show you the proof. I'm just going to show you the end result. And that is cosine squared of some number plus sine squared of that same number equals 1. We could plug in some values for theta and prove that this is true. We're not going to do that, but this is a trig identity. And if you look at what we have -2 cosine of 2 minus 2 sine of 2. And if we factor out a -2 from those two terms, we will have cosine squared plus sine squared. So let's just do it, just for the fun of it. Yeah. So the 3 cosine of t is staying the same. But then we're factoring out a -2 from our other two terms. So when we do that, we have a positive cosine squared plus sine squared. So we just did the opposite of distributing. Normally, if we had something like this, we would distribute the -2 to get rid of these parentheses. We just did that step, but backwards. We took a -2 out. This is all still over 3 minus 2 cosine of t squared. So now, using this trig identity, cosine squared plus sine squared equals 1, this part of our numerator is equivalent to 1. So basically we have 2 times 1 right here. So we can simplify this. We have 3 cosine of t minus 2. Okay, that was example 1. Example 2 is just adding some context to this, and it's quite long. So, do you guys want to break before we start, or do you just want to get it done? All right, I heard one person. That's what we'll do then. Okay, example 2 then. I'll give you all a second to copy this down. Yes. Okay, let's read through this. It says, suppose the amount of money in a bank is given by P of t equals 500 plus 100 cosine of t minus 150 sine of t, where t is in years. During the first 10 years in which the account is open, when is the amount of money increasing? So, asking when a function is increasing or decreasing tells us we have to find the derivative, because that's going to tell us the rate of change, and that's what increasing or decreasing is. That's a change. And then we have to see whether or not the function is, whether the function is positive or negative during the time that it's asking. So the derivative of this function is where we need to start. So we need to find p prime of t. So the derivative of 500 is a constant, so that derivative is 0. You can write 0, you cannot write 0. I'm going to choose not to. Then we have the derivative of 100 cosine of t. The 100 stays, and the derivative of cosine is negative sine. Then we have minus 150 sine of t. The 150 stays, the derivative of sine is cosine. Really the only thing here that we could do, we have 100 times negative sine. We can write that as negative 100 sine of t. Okay. So to see where the money is increasing or decreasing, which this one's only asking about increasing, but either way, we first have to know when the rate of change is 0. That's going to break up our number line into intervals, and we'll test a number in each interval. We've done that before in some problems. So we have to know when this derivative equals 0. And that's going to give us the dividers for our intervals. So we're setting negative 100 sine of t minus 150 cosine of t. We're going to set that equal to 0. Okay, let's add 100 sine of t to both sides. So we're left with negative 150 cosine of t equals 100 sine of t. We're basically trying to get the trig functions by themselves and on the same side. So let's get sine of t by itself by dividing both sides by 100. So on the left side, we can just do negative 150 divided by 100. That gives us negative 1.5 cosine of t. And then let's divide both sides by cosine of t. So we have negative 1.5 equals sine of t over cosine of t. Does anyone know a different way that we can write sine over cosine? Tangent? Yep. So we can rewrite sine over cosine as tangent of t. Okay. This is still not telling us where, like what t values make our derivative 0. We're still not quite there. The way that we can find that is we basically need to know what values of t do I plug into tangent to get negative 1.5. So where is tangent of t equal to negative 1.5? I just flipped the two sides. If we take tan inverse of both sides, actually, that's not one. The tan inverse and tangent cancel out and leave us with t. So t equals tan inverse of negative 1.5. So now we're able to find values of t by plugging this function into our calculator. So tan inverse is second tangent of negative 1.5. We get negative, let's do 5 decimals. So we get negative 0.98279. Nine, 8, 2. Okay. I'm trying to think of the best way to explain this. First of all, this number, negative 0.98279, that's not even in the interval that they're asking. It's asking for during the first 10 years, which would be a t-value of 0 to 10. So having this number set an interval for us does no good. The way that we can find numbers, I'm trying my best to confuse you the least. I'm trying. Okay, don't draw this on your papers, but remember the unit circle and how we can rotate the x-axis up to this point and get some value, some angle measure. But then we also said we can rotate this x-axis one full rotation and some and get the same spot, but a different angle measure. So we basically said whatever the angle measure is plus 2 pi, which is a full rotation. It's 360 degrees. Gets us back to the same spot. Add another rotation. So go around 2 full times and then stop here. So basically we can get this, we can end up in the same spot by taking some angle measure, multiplying by 2 pi n, where n is 1, 2, 3, 4, however many full rotations we can add to this value and get the same spot, but different angle measures. That's basically what we're going to be doing here. And you can do that with any trig functions, sine, cosine, tangent, all those. So to get the correct values that we need for this specific problem, we're going to take our value of t and we're going to add 2 pi n. So we're going to plug in different values of n to represent 1 full rotation, 2 full rotations, 3 full rotations, and so on to get the numbers that we need. I'm going to do that with my calculator. So when n equals 1, I've got t, which is negative 0.98279 plus 2 pi. We get 5.30030, actually 30040. Okay, if n is 2, we have negative 0.98279 plus 2 pi times 2, which is 4 pi. 11.5836. Well, if I'm doing 5, hold on. 11.58358. And that's already out of our range because we're looking just in the first 10 years, which means t is between 0 and 10. So I'm not going to go on and do n equals 3. That's going to be even more out of our range. Oh my God. One moment. Something's happening.